Alright, so for this video, I'm going to be solving the equation x to the power of x is equal to x to the power of 2. So, my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. I'm going to rewrite this problem down here so I have a little more solving space. So my equation is x to the power of x is equal to x to the power of 2. Now the first thing I'm going to do is divide both sides by x to the power of 2. So then these two cancel out, and I get x to the power of x over x to the power of 2 is equal to 1. Now, if I have something in the form a to the power of m over a to the power of n, this is the same thing as a to the power of m minus n. So x to the power of x over x to the power of 2 is going to equal x to the power of x minus 2, which is equal to 1. And now what I'm going to do is I'm going to take the ln, or natural log, on both sides. So I get ln of x to the power of x minus 2 is equal to ln of 1. Now the reason I did this is because logarithms have a special property where if I have something in the form ln a to the power b, I can simply move this exponent b to the front, so this is the same thing as b times ln a. So in this case, I have ln x to the power of x minus 2, and I can think of x minus 2 as b and just move it to the front. So this is the same thing as x minus 2 times ln x is equal to ln 1. So now, ln 1 is actually equal to 0. So I get x minus 2 times ln x is equal to 0. And now this gives me two equations. I get x minus 2 equals 0, and also ln x is equal to 0. So, for x minus 2 equals 0, this is a simple equation. All I have to do is add 2 on both sides, and I get x is equal to 2. So that is my solution. And now for ln x equals 0, what I'm going to do is take e to the power of both sides. So I get e to the power of ln x is equal to e to the power of 0. And the reason I did this is because e and ln x cancel out, so I'm left with x is equal to e to the power of 0, which is 1. So now to check, my equation is x to the power of x is equal to x to the power of 2. So if I plug in 2, I get 2 to the power of 2 is equal to 2 to the power of 2, meaning 4 is equal to 4. If I plug in 1, I get 1 to the power of 1 is equal to 1 to the power of 2, meaning 1 is equal to 1. So both of them are right. Alright, so in this equation, I'm going to be solving 3 to the power of x is equal to x to the power of 9. So, to solve this, what I'm first going to do is take the power of 1 over 9x on both sides. So I get 3 to the power of x to the power of 1 over 9x is equal to x to the power of 9 to the power of 1 over 9x. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of x to the power of 1 over 9x is going to equal 3 to the power of x times 1 over 9x. And this is going to equal x to the power of 9 times 1 over 9x. Now x and x in the denominator here cancel out. So I get 3 to the power of 1 over 9 is equal to x to the power of 9 and 9 cancel out, 1 over x. Now, one over 9 is the same thing as 3 over 27. So now I can rewrite this as 3 to the power of 3 to the power of 1 over 27 is equal to x to the power of 1 over x. And 3 to the power of 3, well, that's equal to 27. So I get 27 to the power of 1 over 27 is equal to x to the power of 1 over x. And notice how these two are in the same form. A number to the power of 1 over that same number, meaning x is equal to 27. So now to check, I can plug this in to my equation. 3 to the power of x is equal to x to the power of 9. X is equal to 27, so I get 3 to the power of 27 is equal to 27 to the power of 9. And 27 is the same thing as 3 to the power of 3. So I get 3 to the power of 27 is equal to 3 to the power of 3 to the power of 9, which is equal to 3 to the power of 27 is equal to 3 to the power of 3 times 9. And 3 times 9 is 27, so I get 3 to the power of 27 is equal to 3 to the power of 27. And this is right, so my solution over here is right as well.